I'm sure you guys are really heartbroken about this, but this is the last unit of the year. Can you believe it? Well, what is the last unit of the year, you ask? The last unit of the year is geometry. Geometry, yay! So what is geometry? Geometry is the study of shapes. Since we're studying shapes, guess what I drew? A shape, yay! Okay, so two things. There's perimeter that we're going to talk about today, and then there's area that we're going to talk about today. Both dealing with two-dimensional shapes. Two-dimensional meaning two sides, length and width, or base and height. Two sides. It's flat, two-dimensional. Perimeter and area. So the first one with perimeter. Perimeter means distance around the shape. So that would be if I'm going around this shape. I would need to add up this side, plus this side, plus this side, plus this side. I like to think the word perimeter has a T in it. That T kind of looks like a plus sign, so we're going to use addition to find the perimeter. Also, you could think about perimeter is often associated with fences. If I were to put a fence around this shape, how much would I need? That would be perimeter. It goes around the shape. So the other word I mentioned was area, okay? Area is often associated with paint. It's how much you need to fill in an area. Fill in an area, okay? So it would be how many square units are in the shape? How many square units are in the shape? So if I were to fill this in, I want to know how many of these squares are in the shape. So to figure that out, we're going to discuss some formulas that you can use to find the area of shapes. That's what we're going to talk about today. But area is we want to know how much goes into this entire shape. The inside of the shape is area. So right now we're going to try to determine the area formula for a rectangle. Okay, so a formula is a concise way of writing a mathematical statement using symbols. So what we're calling symbols here is going to be letters, variables. You also might notice that there is a capital A for area. Do you remember when we talked about using capital letters for variables and we said don't do it because capital letters are reserved or saved for formulas? So we are using a capital A because that is what our formula is equal to. A is the area, so that's why we're using a capital A. That's okay. You should use a capital A to represent area. So originally, I was given the side length of 4 and 3 for this shape. But what if I didn't know these, okay? So to find the area of this shape, I could count all the blocks. But if I don't know one of these side lengths, we can still figure it out, okay? So there are 12 shapes, 12 square units inside here. I could figure that out by counting, but I could also figure that out by using multiplication. I could do 4 times 3, which equals 12. So I took my 4 and my 3 and multiplied them together to get 12. That will work every time. So our area formula for a rectangle, instead of using 4 and 3, we're going to replace these with variables. So sometimes this is called length and this is called width. But right now we're going to call them base and height because I'll explain in a second with the next shape. But I'm going to call 4 the base. So I'm going to multiply the base times, and then I'm going to call 3 the height. Oops, I spelled that wrong. I always spell height wrong. H-E-I. So base times height. Okay? You could also write it, like I said, sometimes this pink one is called the length times the width. So base times height or length times width are the same thing. Either one of these will get us the formula for the area of a rectangle. So the area formula for a rectangle is area equals base times height or area equals length times width. These mean the same thing, but like I said, right now we're going to use base times height because I'll explain here in a second. There's a reason. Okay, the reason why we usually refer to it as base times height is because of this shape, parallelograms. So right now we're going to talk about parallelograms. So a parallelogram is a shape that has two sets of parallel sides. So these sides are parallel, meaning they will never intersect, and the bottom and the top are parallel. They will never intersect. All we did was we basically took our rectangle and we smushed it to the side. So I want to show you a little example here. I'm pretty proud of this. I just found this stuff in my house and made it. Look at me being so resourceful. Okay, here's our rectangle. 4 and 3. So we still got a base of 4 and a height of 3 here. So what we did with the parallelogram is we went to the side. So what I did is I want to show you what happens to our height when we do this, okay? So I also have this other stick that I have marked the height on right here, okay? So do you see that green line there? So that is the height of our rectangle, 3. So watch what happens when I shift to one side. Is my height still in the exact same spot? No, isn't it a little bit lower? So the more my angle is, my height is getting smaller and smaller. So while this side length is staying the same, my height is actually getting smaller. So that's why we're using base times height, because when we're calculating the area of a parallelogram, we still use the height, but the problem is the height has to be given to you because the height is not this side length. No, that is not this side length. This is not the height of a parallelogram. Look how tall this is. Is that the same as 3? No, remember the 3 is that green line. So if that green line is 3, when I shift over, 3 is no longer my height. It's not at that green line anymore. Okay? That's why. All this being said, to bring us back to our parallelogram. So 4 is still our base. So our base is staying the same, and we still need to multiply to get our area, but we are not going to use this 3. We are not going to use the side length. We need to use the height, okay? Height is different than side length. 3 is not the height. Remember, our line was changing on our stick. So our area formula is still going to be base times height, h, but 2.5 would be our height because the height makes a 90-degree angle with the base. A 90-degree angle means a right angle, like the corner of a square. Perfect right angle. It's usually marked with the little square in the corner. So if you ever see a square in the corner, that means that that line is the height of the shape. So 2.5 would be the height of our shape here. So if I was going to calculate the area of this shape, I would say area equals base of 4 times the height of 2.5. Not 3, 2.5, because 3 is a side length. We don't use length. We use the height, which makes a 90-degree angle with the base. So then I could determine that area equals 10 square units because 4 times 2.5 is 10. So for the love of math, hear me out when I say this. The height of a parallelogram is not the side length. It is whatever makes a 90-degree angle with the base, straight up and down. Do not use the side length. Do not use the side length. You can use the base, but don't use the side length. Don't use the side length. Use the height. There is that difference. Okay? Okay. So your notes so far should look something like this. Rectangle. The area formula is A equals B times H. B times H. B means base. H means height. Or you can have area equals length times width. But remember, we're not really using that one right now. Parallelograms. The area formula is also A equals base times height. B equals base. H equals height, and then remember the height of a parallelogram makes a 90-degree angle with the base. So important. So this is what your notes should look like right now. So I want you to scroll down to page 2 on your notes, okay? There should be a pink section that says area of parallelogram. These are the examples that you need to do today. So first, the area formula for the area of a parallelogram is area equals base times height. Now, I don't have a picture of the shape on my board because it doesn't fit, but I put it up on the screen for you here. So we're using this picture to create this perimeter and the area. So looking at that picture, to calculate the perimeter, we need to go around the whole shape. So we are going to add up all of the side lengths of that shape. So I'm just going to start with 1.4 plus, and then if I were to go around the top, what is the length of that top? It's not written there. But we know that it's the same as the bottom in this case, because if it's not written, you can assume it's the same as another length that you were given, or we also know that it's a parallelogram. 2 sets of parallel sides would force it to be the same as the bottom. So 1.4 plus 4.5 plus 1.4 again plus 4.5. So I just went around the outside of the shape, adding up all of those side lengths with a capital P over here for a perimeter. So then, what do I get when I add up 1.4 plus 4.5, which 4.5 is the same thing as 4.5, plus 1.4 plus 4.5? You would get 8.8, and then what was the unit we were given? We were given inches. So we would say the perimeter around this shape is 8.8 inches. Don't forget your unit. So now we're going to talk about the area of this shape. Well, I'm going to start by first writing down my formula. You should always write down your formula. So I know that area equals base times height. That should be your first line with the formula always for area. I want to see that formula written down right here. Next, I'm going to fill in values for the base and the height. So I'm going to say A equals, so what is my base? My base is 4.5 times, okay, well, what is my height? Do not say 1.4. 1.4 is not our height. Our height has to make a 90-degree angle with the base. So what number on that picture makes a 90-degree angle with the base? 2. So our height is 2 because it makes a 90-degree angle with the base. So now I would multiply 4.5 times 2. 4.5 is the same thing as 4.5. So I could type into my calculator 4.5 times 2. Well, what is 4.5 times 2? 9. And then here's where it gets a little tricky, okay? Our unit of measurement. When I'm calculating the area and I am multiplying, when you multiply inches by inches, it becomes inches squared or square inches. Inches to the second power. When you are multiplying your area, your unit will be to the second power because you are multiplying inches times inches. Inches times inches is inches to the second power. So I would say the area of this shape of the parallelogram is 9 square inches. 9 square inches, that's how I would say that. So notice these 3 lines. Started with my formula, filled it in with my values, and then got my answer. I want to see these 3 lines when you are finding the area of a shape, always. Formula, fill in the numbers, answer. That's how it should look. Now that we've done an example together, I want you guys to finish the last 2 examples on that page. So the second page in your math notebook, the other 2 examples of parallelograms, just parallelograms, submit that, make sure that it looks good, okay? Honors, make sure you watch the second video that you need to watch today. But regular, once you finish those 2 examples, you are good to go. That's all you have to do. Honors, watch the second video. You have more to do. Okay, bye!